Question number 1. 2.8 minus 1.4. To work out decimal arithmetic, we need to use the vertical calculation. First, we need to remember, in decimal arithmetic, we should align the decimal point, and then calculate from the right. 8 minus 4 equals 4, and 2 minus 1 equals 1. In the result, also ensure the decimal point should be put under decimal point. That's it. So the result should be 1.4. Question number 2. Which of the calculations below is correct? Actually, as you can see, in this operation 68 minus 40 divided by 4, there are both subtraction and division. When there are no brackets, we need to do the division first, because it is much more convenient than subtraction. So when we have these two operations, we do division before subtraction. Here we should get 58. That B is correct. In A, A did subtraction before division. It's wrong. In C, after it do the subtraction first, but it switched these two operations. So it makes no sense and it is wrong. In D, still after it calculates the division first, it do the second step wrongly. Actually, we call the order as Boltzmann order. When we have both times, divide, plus, minus, we always do the more convenient operation first. But if there are brackets is always the first one to consider. Question number 3. Which shaded part represents 4 out of 10 in the figures below? First, we need to know the definition of fraction. The number at the bottom, we call that as denominator. Denominator means how many equal pieces we divide the whole thing into. And the number on top, we call this as numerator. It means how many pieces we have picked. So if that is 4 out of 10, the nature, it means we have divided the whole thing into 10 equal pieces. And we choose 4 out of the 10 pieces. That's why C is correct. If we use fraction to represent A, B, D, you will notice that in A, the whole thing has been divided into 4 equal pieces, and all of them have been picked, so it is just one whole. In B, half of the shape is shaded, so we can use 1/2 or 1 out of 2 to show it. But also, as you can see, actually, it has been split into 8 small pieces. So the denominator can also be 8, and 4 are shaded, 4 out of 8. The last one, 4 out of 9 has been shaded, and we have no other option to represent it. That is the nature of fraction. Question number 4. The school buys 9 boxes of pencils as prizes. Each box has 125 pencils. How many pencils are there in total? If we already know one box has 125 pencils, to find 9 boxes, to find how many pencils does it have? Actually, we just need to multiply the number of boxes by the number of pencils in each box. We can get the total amount. It should be 1,125. In this case, we can get it quickly. When we are calculating this, first you can use the vertical or the long multiplication to do that. If you are familiar with the two good friends in multiplication, 125 times 8, you can also get it quickly. We just need to add one more 125. It is also 1,000. It is also 1,125. So B is correct. Question number 5. Observe the statistical chart. Which option is incorrect? Let's see. First, we need to know how to read this chart. On the left, these numbers means how many shapes are there. And for the horizontal row, it means what kind of shape it is. So as you can see, we had better use a ruler to do that. First, we can get the star, there are 8. For the circle, the number is 6. For the triangle, the number is 12. And for the last thing, the number is between 6 and 8. So it is 7 because every gap has been spaced equally. That's how we get it should be 7. Now we can decide which one is correct, which one is incorrect. First, among the shapes, triangle is the most. Even if we didn't know the specific amount, you can see that in the picture because for the bar of the triangle, it is the highest. So it is correct. B, circle is the least. Yeah, as you can see, the bar of the circle is the lowest. So it is correct. C, star is one more than square. Let's see, there are 8 stars and 7 squares, so it is also true. The last one, there circle is 2 less than square. Let's see, circle. There are 6 circles and 7 squares, so the difference shouldn't be 2, it is 1. That's how we get D is wrong. Question number 6. Max's birthday is coming. His father wants to choose a pen and a diary as presents for him. How many different ways are there to choose? As you can see, for diaries, there are 4 different types. And for pens, there are 2 kinds. Well, we want to know how many combinations are there. For the first diary, there are 2 pens to be combined. For the second diary, there are also 2 pens to be combined. If there are 4 diaries, every has 2 combinations, so altogether there should be 8. Actually, this is also called the principle of multiplication. When we want to combine 2 different things, just multiply the number of types of each kind, then we can get the total amount of combination. Before currency appeared, people traded things for things. If one sheep could trade for 3 geese, one goose could trade for 2 chickens, then how many chickens could 2 sheep trade for? So if that is a math problem, the first thing we need to do is always to translate the sentence into a math equation. First, we know one sheep could trade for 3 geese. So they are equal, they have the equal value. One goose could trade for 2 chickens. And how many chickens could 2 sheep trade for? Let's see, first we don't know the direct relationship between sheep and goose. But here, as you can see, we know one goose could trade for 2 chickens. If there are 3 geese, how many chickens should be there? Good job. 3 times 2 equals 6 chickens. So we can get one sheep can trade for 6 chickens. Then if there are 2 sheep, so we should trade for 6 times 2 equals 12 chickens. That's how we solve this one. Translate sentence into math models, and then it is much easier for us to find the relationship. Question number 8. What can Leo see in the right figure? And first, let's see. When Leo sees these things from the back, now you can put a pen and a ruler in front of you. When you look at it in the front, if the ruler is on the right, when you look then from the back, the ruler will come to the left. So here we can decide it at once. First, if the clock is still on the left, it must be wrong. Because if we look at it from the back, it shouldn't have the same relative position as the front. Second, as you can see, the lamp is pointing to the clock. So when we look from the back, the lamp should also pointing to the clock. In this case, we have already got it should be C. And there is a more easy way to get it. Because from the back, we shouldn't see the front of the clock. We should see its back. So A and B couldn't be true. That's how we get it should be C. Question number 9. How many zeros are there in the end of the product of 450 times 8? So we must be careful of that. When we multiply a round number by other numbers, first we can put aside the zero, just to do the other part. That will be much easier. 45 times 8. 5 times 8 makes 40. So carry 4 over the tens place. 4 times 8 equals 32. 32 plus the 4, which is 360. Then, please remember, we need to add the zero back. So, here should be 2 zeros in the end. Another way to do it, just do the 3 digit multiplied by 1 digit. 0 times 8 equals 0. 5 times 8 equals 40. And then, 4 times 8 plus the carried 4 is also 3,600. There should be 2 zeros at back. If 500 and something thousand and 987 is approximately equal to 500,000, then which can be filled in the box? First, we need to know what does this symbol mean. Actually, it means is approximately equal to. In other words, they are not equal. It's a round. We want to round this number to 500,000. If so, the number in the thousands place shouldn't be greater than 5. If that is equal to 5 or greater than 5, when we round it, we need to make it into a bigger number, the closest, the greater number, which is 501,000. So that's why here we have only A to choose. Question number 11. Observe the following figures. According to the pattern in the figures, find how many points there are in the fourth figure. Let's see. Here in the first shape, you can see. Actually, we start in the first row, there's only one thing. And the second row, 2 dots. The third row, 3 dots. We move on to the second shape. The first row, there are 2 dots. The third row, 3 dots. The fourth row, 4 dots. In the third figure, the first row, 3 dots. The next, 4 plus 5. So when we move to the next one, could you please tell me how many dots should be there in the first row? Good job, 4. We are keep adding 1 in every single row. So starting from 4, keep adding until the third number we can stop. Then we can get it should be 4 plus 5 plus 6 equals 15. So this one, D is correct. Question number 12. As shown, if cup 1 is filled with water, there should be water left in cup 1 when pouring the water from 1 to 2 until 2 is filled. If cup 1 is filled with water, cup 3 cannot be filled by the water in cup 1. Which cup has the smallest capacity? So we have to translate the sentence into math models again. Based on the first sentence, we can know in the volume, the capacity of cup 1 should be greater than that in cup 2. That's why when we pour the water in cup 1 into cup 2, there will be something left. And based on the second sentence, if cup 1 is filled with water, but cup 3 cannot be filled by the water in cup 1. So we can get cup 3 should have a greater capacity than cup 1. Based on this, you can compare that. 3 is greater than 1, 1 is greater than 2. So cup 2 should have the smallest capacity. That's why here we need to pick B as the result. Question number 13. Triangle, circle, and a square each represents a number. If triangle plus triangle plus triangle equals 60, square times triangle equals 360, and circle divided by square equals 6, what is the value of circle? So first, if there is only one shape in this equation, we should be able to work it out. Because actually when we add triangle 3 times, it is equal to triangle times 3 equals 60. So one triangle equals 60 divided by 3, which is 20. And after we work out the value of triangle, we can replace all the triangle by 20. So we have the second thing. If square times 20 equals 260, to work out square, we need to divide the product by 20, which is 13. And the third one, it is a relationship between circle and square. Now we can replace the square by 13. So it is circle divided by 13 equals 6. To find the dividend, we need to multiply 13 by 6. In this case, we can get the value of circle should be 78. C is correct. Question number 14. Lisa solves such a problem after a number adds 3, subtracts 5, multiplied by 4, and divided by 6. The result is 16. Find this number. So first we had better list this process in their flowchart. A number adds 3, then subtracts 5. Next, multiplied by 4, and then divided by 6. Finally, it will become 16. Now we just need to work backwards. When we move forward, it is divided by 6. If we work backwards, it should become times. And the times become divide because multiplication and division, they are inverse. And then subtract should become its inverse, addition, plus 5. And plus become minus. Now we just need to calculate from the bank. 16 times 6 equals 96. And then divided by 4 equals 24. 24 plus 5 is 29, and 29 minus 3 is 26. So the answer should be B, 26. To work out this problem, first we need to look at these two diagrams. It gives us, as you can see, there are two shapes. If you just compare that, we can see in the first row, they look the same. In the second row, they have the same color in the second column. But if you move on to check it, you will find, wow, actually, we can't find any pattern. So we had better think from another perspective. If we just focus on the right thing, because it is complete. In the first row, we have yellow, red, green, blue. In the second row, we have green, blue, yellow, red. In the next row, we have blue, yellow, red, green. The last row, we have red, green, blue, yellow. Have you noticed something? No matter it is in a row or column, do we have the same color? If so, in the first picture, add the box with a question mark inside. In this row, we have already got yellow, red, and green. What color is missing? Great, it is blue. Question number 16. In the figure, the numbers on the left side of each row and on the top of each column represent the number of consecutive black cells in that row and column. After coloring the figure according to these numbers, which of the following figure is correct? Let's check it quickly. First, because the number 1, for example, on top, it means there should be only one consecutive black cell. But in this row, we have 2 black cells, so it must be wrong. In this case, we can also exclude B. A and B shouldn't be correct. And then let's see. In the second row, we should have 2 In the second column, we should have two consecutive black cells. Both C and D are correct. But if we move on to the third column, it's also true. So that means in this column, there should be only two consecutive black cells. That's how we exclude D. So only C is correct. You can also check the other rows and columns. Actually, this is a really interesting math game, nonogram. If you are interested in that, you can try to find more on the internet or just ask the teacher for more games. It's quite interesting. When we have these numbers, sometimes we can make some lovely animals like cartoon characters you may be interested in. Question number 17. The figure below is formed by several squares. How many squares are there in the figure? First, if you just count it one by one without any order, it's really easy to miss or repeat some squares. So we had better decide the order and classify different squares. The basic way to classify squares is by their size. If there is only one square on every side, we call this as 1 by 1 square. So first, let's see how many 1 by 1 squares are there. First, you can see that in this part, there are 3 rows and 3 columns, 9. And then we just need to keep adding another 5 and another 5. So added by 2 5s. In this case, we can find how many 1 by 1 squares are there quickly. 19. Don't count it, try to calculate. That is more efficient and accurate. Then, if we move on to a bigger size, 2 by 2 square. First, still we need to delineate. In this part, 2 by 2 squares, we just need to count the center. So 1, 2, 3, 4. We have 4. If we continue to move on, you can see there is another one. There is another one. So for 2 by 2 squares, we just need to count the center. Because if the center is here, we can't make a 2 by 2 square. So the center must be inside. In the first row, we have 2. In the next row, we have 3. If we move on, we have another 3. And in the last row, we have another 2. So altogether, 2 times 2 plus 3 times 2, because there are 2 2s and 2 3s. It is equal to 10. In this case, we can calculate it really fast. If that is a 3 by 3 square, let's see. This is 3 by 3 square. We just need to ensure we can find the square in the middle. We can get it quickly. If so, there is 1. And then there is another one. This kind of square in the middle, it should have squares surrounding that. So there is another one. Altogether, 3. And do we have a 4 by 4 square? Actually not. So just to calculate the total amount, by adding these numbers together, 19 plus 10 equals 29. 29 plus 3, which is going to be 32. Done. That's how we calculate efficiently. Question number 18. Car A left school heading to the hospital, while car B left the hospital heading to the school. These two cars met 40 kilometers away from the school. They drove forwards after meeting each other and returned as soon as reaching the school and the hospital, respectively. They met for the second time, 35 kilometers away from the hospital. How far is it from the school to the hospital? Actually, it is a distance problem, and you can see there are too many conditions. So to simplify the relationship, we had better draw a diagram. First, we need to draw out the distance from the school to the hospital. And then A starting from the school heading to the hospital, while B starting from the hospital heading to the school. At first, they will meet each other at the point 40 kilometers away from the school. So in other words, this time, A has drove 40 kilometers. And by now, you can see the distance A drove added by the distance v dropped, just equal to the distance between the two places, the total distance. Then they will move on, so I use another color to represent the second time they continue to draw. When they reach the destination, they will return directly, like this. And this time, they will meet each other. A also returned. Yeah, as you can see here. Okay, done. So this time, the places where they meet each other is 35 kilometers away from the hospital. And let's see, actually, altogether, they have drove 3 times as long as the distance between school and the hospital. So in this case, we can see when they have drove one total distance together, A will drove 40 kilometers, but now they have drove the total distance. So in other words, A has drove 40 times 3 equals 120 kilometers in total. But let's see A's distance. Actually, it is just 35 kilometers longer than the total distance. So we just need to take away this 35 to get the total distance from school to the hospital, which should be 85 kilometers. Done. That's it. In distance problems, the relationship is tricky. We had better draw it out to simplify the relationship. Question number 18. In the long multiplication below, some digits are covered by rounded squares. What's the result of the vertical expression? So first, let's see. Actually, we just got several numbers. We don't have much information. But at least we need to realize if we multiply a 3-digit by a 2-digit, the first row comes from something ending with 5 times the 1st digit, and the second row comes from the first row times 2, and the last end result comes from the 2 results added together. And another thing, for the first row, when we multiply a 3-digit by something equals a 3-digit. But when we multiply the same number by 2, it becomes a 4-digit. Obviously, the second row is greater than the first row. So that means the number in the ones should be less than 2. But the digit less than 2, we just have 0 or 1. In the tens place, we got 4. So the ones in the multiplicand, it can't be 0. It can only be 1. As long as we get this is 1, 1 times 5 equals 5. We can know these two numbers should be 5. And then 1 times the 10th digit equals 4, so it is 4. Next, after we know the 10th is 4, in the second row, 2 times 5 equals 10, carry 1 over the next place. 2 times 4 plus the carried 1 equals 9. And now we can get, in this column, we have something plus 9 equals 7. In addition, we can never get a smaller amount, so actually, there must be exchange. But when we are adding to a single digit, the exchange can only be 1. That's because even if we are adding the greatest single digit, we can only get 18. The tenth is 1. So in this case, actually, something plus 9 equals 17, and this number should be 8. As long as we know that is 8, we can get 1 times 8 equals 8, so the hundredth is just 8. Actually, it becomes we are doing a 3-digit times a 2-digit now. In the second row, 2 times 8 equals 16. And we just need to add up all these numbers from the right. 5, 4, 17, carry 1 over, so 7, 1. the end result should be 17,745. That's how we work it out. Question number 20. Add consecutive whole numbers from 1 and split all added number into two groups to ensure each group can make the same value. Like from 1 to 3, if we split it into 1 and 2, another group has 3, they will make the same value. From 1 to 20, if we put the first 14 numbers in one group and the remaining 6 numbers in another group, they will also make the same value. Besides the two examples mentioned above, what is the shortest equation that can be written this way when only considering whole numbers? The first way is to keep adding, because now we have already got 20. The shortest equation, at least it shouldn't be less than 20. And then, after you check the next number, we need to keep checking until we get it. You can use the trial and error method, but you may realize if we use that method, too tricky, and you don't have enough time to do that in exam. You are encouraged to try this method after exam. So, when we have this kind of question about number theory, we had better combine that with diagram. For example, if I use this kind of letters to represent, we will keep adding consecutive whole numbers from 1. So the first letter means 1. The next letter is 1 more than the previous number. Keep adding until the last number. And the second, because we will split it into two groups, the dotted line means I split it into the first group and the last group. Because the second group's numbers are greater than the first group, that's why the right group has a smaller size, has a smaller distance than the first group. Then I need another picture to show the relationship. It's like because I want to know the relationship between those two groups in a better way. So here, as you can see, actually, they have the same part. If I make this part reflected on the right, in this case, we can get this part is equal to the right one. It's just like I flipped the first group to the right, and then I get the second figure. In the second figure, we can get B plus C should be equal to A plus C, because this is the model we have made. We split it from this part, from this dotted line. When we add from the first number to the last number, it should be equal to the next number added to the last number. If we get this part, we can get another conclusion. If we take away the same part, A should be equal to B. And let's continue to see. If I use the capital letter A to represent this distance, the capital letter B to represent this distance, here you can see. Actually, if I want to know the total of part A, it is we add from 1 to the last number A to get the sum of the first part, which is just A. A is the size, and the capital letter is the number, is the distance. So actually, we're adding from 1 to until we get A. So it becomes a arithmetic sequence to get the total of that. If we write from A to 1, you can see every single column it will make 1 plus A. And there are A numbers, so there are A columns. But we calculate every single number twice, so we need to divide it by 2. That's how we get the total of 1 plus 2 plus A should be equal to A times A plus 1 divided by 2. And the second, if we look at B, because the difference between every two adjacent numbers is 1, so this vertical line is also 1. In this case, we can consider B as we add from 1, and this is 2, and this is a 3, 1, 2, 3. But actually, it is not 1, 2, 3. It is B, because you can see I use the letter B to represent it. So it's like we add for the part B. It's like we add from 1, 2 until we get B, and add it back until you get 1 again. For this kind of thing, we just do one more step. Cut this part, and put it here. You can see we can make a square. So B's value should be equal to B, capital letter B, multiplied by B squared. That's how we get it. Now, after we got A and B, we also know A is equal to B. So A times A plus 1 over 2 should be equal to B squared. If we continue to check this operation, you can see A and A plus 1, they are two adjacent numbers. So if adding two adjacent numbers shouldn't have any other factor except for 1. After we realize this, another thing, one of them must be odd and the other one must be even, because odd and even, they are adjacent. If so, no matter A is even or A plus 1 is even, these two parts after one of the even divided by 2, they should be a perfect square. What do we mean the perfect square? That should be another number squared. Only in this case, the product can be the square number, can be a number squared. So let's check. For example, question it told us 1 plus 2 equals 3. So in other words, the odd among that, because it must be an odd times an even divided by 2. And the odd must be a number squared. For example, I use a letter C. And the even number must divided by 2 should also be a natural number squared. Only in this case, we can get another number squared. Just put C and D in a group. That's how we get B. So B should be equal to the product C and D squared. Now let's see. For odd number, the first squared number is just a 1. So, case 1, when the odd number is just 1, then the even number should be 2 at least, because 1 plus 1. Then 2 divided by 2 is just 1, so it's also a perfect square. This one can work. And the second case, when we move on to check the next odd one, because only odd number squared equals an odd number, so 3 squared equals 9. So in this case, even may be 10, but if so, 10 divided by 2, it's not a perfect square, so it's wrong. Even can also be the smaller one, which is 8, 9 minus 1. If so, it's equal 8 divided by 2 equals 4. It is just a perfect square, so this can work. But still, it's too small because we want to find something after 20. The next one, when the odd number is 5 squared, equals 25. The even, maybe 25 minus 1, which is 24. But 24 divided by 2 is 12. It's not perfect square. And the even can also be 26. But when we divide 26 by 2, still you can see it is 13, not a perfect square. So this one cannot work. Sorry, I don't have enough space. So I write the following step here. The case 4, the fourth case. The next odd number is 7. 7 squared equals 49. In this case, the even may be 49 minus 1, which is 48. But 48 divided by 2 equals 24. It's not any number squared. The even can also be 49 plus 1, which is 50. 50 divided by 2 equals 25. And the 25 is the square of 5. So this can work. And when the odd number is 49, the C should be 7. So in this case, we can get B is just 7. B is just 7 times 5, which is 35. And A should be, let's check it quickly. If so, A is just like here. Well, we assume one of these two numbers is 49. The smaller one should always be A, because the bigger one is 50. So A is just 49. Well, A is 49, B is 35. Here you can see this is also B, this is also B. The original number we are going to add should be A plus 2B, which is going to be 49 plus 2 times 35. So it should be 49 plus 70 equals 119. This is the shortest equation because the previous one is the number the question told us when the odd number is like 25 and the other one is 20. Well, the other one, when the odd number is 9. And then the even part, because the square of that is 2. So B should be equals to 2 times 3, which is 6. And 9 plus 2, 6. Sorry, it's not 9. So actually, this is much smaller than that. So here we can get when the odd number is 9, among that, the smaller one is 8. A is 8. And then the even one is just 3. C, because it equals 9. And D is just 2. So 3 times 2 equals B, which is 6. 8 plus 6 times 2 is just 20, the example it gives us. So that's why the shortest equation should be from 1 to 119. That's how we get it by using the diagram to analyze this question.